So let's take an alternative approach to the camera follow of our player sphere. Now, this is going to be a slightly less dynamic solution. Um, I'm going to move forward with the previous solution throughout the demo, but I do want to demonstrate an alternative. And in order to do this, what I'm going to do is I'm just going to deactivate the state machines for the controls that we set up before, and also the script. So in other words, I have the player selected, and I want to deactivate the player control because, again, this player control, the one that we just set up, relies on getting the camera position and having a mouse orbit on the camera. So I'm going to remake the state machine for an alternative setup. In order to do that, what I'm going to do is, with the player selected, I'm going to go to the inspector, and you'll notice that there are components for each one of the state machines that are attached. Now remember, I have two different state machines attached to my player. I have a player zoom, and I'm just going to uncheck that. That'll deactivate that playmaker component, or that playmaker state machine. And I have one here for the player controller, so I'll uncheck that as well. In fact, I'll even collapse these like so. I'm going to add an additional state machine, so I'll add a state machine, and I'm going to call this alternative, or alt player control. And this will be just a kind of a simple setup, very similar to our initial get access vector scenario. So I'll set this up really quickly with an input. I'll do a quick get access vector, and I'm going to store the player movement in vector 3. And I'll add this. I'll go back to the state, and I'll store the vector. Now I'm not going to goof around with the speed or the power in the same way that I did in the previous presentation, and so I'm just going to increase this multiplier here. I'll jump in and do a quick add force through physics, and we'll add force at the vector of the player movement vector. So we're getting the axis vector and translating that into an add force, and we're just using the world coordinates here. So this is a pretty simple, straightforward solution. You can see mine's not working. That's because I missed a step here. I forgot to check every frame on the add force, and that's just overlook that for a second. So I'll test this, and that just stresses the importance on testing your state machines as you build them, because we don't want to build really complex state machines and then have to go through and figure out at the very end what could possibly be going wrong. As long as we're testing along the way, taking that iterative approach to design, we can figure out what the problem is as we create them. So I got a real simple setup here. My camera, you'll notice, is still following the sphere. So I'm going to go disable on my camera. I'm going to go find the mouse orbit script, and I'll just disable that. And I'll collapse that down as well. So now I'm back to this kind of security cam view, and maybe that works for your level, but in the event that I want to follow this player around, if this player were not rotating, so we're applying force, which is ultimately causing the player to rotate, one really quick solution would be maybe we could take the main camera and make it a child of the player object. Now we're going to have a pretty serious glitch with that, because as we start to roll, we're actually rolling with our player. So that's not going to work in this situation. But if this were like a car or a cube or some other kind of player that was not rolling, that would be a real simple fix. But because it rolls, we have to we basically got to track the position of this object in space. And so what we'll do this on the camera. I'm going to create a state machine on the camera, and I'm going to go into the transform category, and I want to do a get position. And we're going to get position. Now I'll want to store the X and the Z position because I'm only concerned about the X and Z. I could do this, store this in a vector, and then split the vector out like we did in the previous demonstration for our player controller. But I'm just going to do a real simple solution here. I'll say X position and set that as a float, and I'll also make one called Y position. And I'll go back to the state. So we'll store the X, excuse me, X position, and actually I don't want the Y position. I need to go back to my variable. I wanted this to be Z position. I'll go back to state, And under Z position, I'll just record both of those in a variable. So we'll be capturing this every frame, and I'll hit the play button. Now this is currently getting the camera. So we've attached this action to the camera. That's why the game object that we're tracking here is the owner. We don't want to do that. I'm going to specify the game object, and I want to track the position of player. Now, of course, we could have done this in the player object and had it get the position of itself. And then we'll do a set position. So we'll do a set position. And this time we'll use the owner because we're using the camera as the owner object here. And I'm going to set the position to X of the player. And I'll set the Z position. And we'll do that every frame. And so now when we hit the play button, our camera, we're a little misaligned here, but you can see that our camera is moving around and following the position of the sphere. Now, the glitch that we're having is that it doesn't seem to be controlling the Y position here. Let me just back this off and try to reposition this. There we go. Hit the play button. Yeah, that just kind of snaps back. So what we're going to do is we're going to set the position. We're going to set the Y position, and we'll just set this manually, say to let's try 10, see if that works. So I'm going to go back into my state 1, and rather than saying Y position equals none, I'm just going to hardwire a value in here, and I'll try 10. And we'll hit the play button and see if that works. 10 did not work. Let me see if I change this value. Okay, so it seems to be working. We're moving up and down, but really what I want to do is it looks like I'm probably going to want to be able to move back in space. I want to move backwards on the Z. So what I need to do is I need to modify the Z value. We're getting the Z value, but then we want to throw a little math on that Z position so that it's not, so it's basically offset from the current position. The problem is our camera is hovering right over top of the sphere. So unless we wanted to do a quick fix and take our rotation and kind of point straight down at the ground or somewhere close to straight down at the ground, I mean, that might solve the problem. But let's assume we want a little more perspective here. So again, just rotating the camera might work, but I'm going to set that back closer to about 45 degrees, which was originally about where it was at. We could do a little trickery with some math. We could take that Z position, and as it's happening in real time, and we could subtract from it. So I'll just go in and do a little math on this, and we could do either a float add or a float subtract. We'll just do a float subtract. And I could either add a negative number or just subtract a real number. And I'll subtract from the Z position, and let's go back, let's subtract 10. And we'll do that every frame. And let's hit the play button and see what we got. There we go. So now we're offset. 10 might be a little too far back. I might want to move that up so that the player character is right about here. So I can actually play with this in real time to figure out what that value is, and 5 seems to be the right value. So I'll just grab this, kick that number back down to 5. And so the basic logic here is that I chose to do this on the camera, but we actually could have done this on the player. The difference is what we're getting the position of and what we're setting the position of. Because I chose the camera to build this machine on, we're getting the position of a specified game object, which is the player. We're storing the X and Z position of the player, and we're storing that every frame. We're then setting the position of the camera, and we're setting it to the X and Z position of the player, and we're doing that every frame. And that causes the camera to basically move with, or essentially be, kind of a child in some ways of the player character. Now, the only glitch was that we had to offset the camera because it was using the exact same Z coordinate, which was putting our camera right above the sphere. And we were able to correct for that with just a little bit of math here and do a float subtract. And we're doing that every frame. That'll cause that offset. So a different camera setup here so we can stay in a fixed perspective. And that way we can take a lot of control over this. So just 2 different ways to control this. I would say this would be more appropriate for a tablet style gameplay because you don't have to worry about controlling the camera. Or maybe you could build a scenario where you can control the camera, but it's not You know, you could do some real basic controls like maybe zoom out here or adjust the rotation angle of the camera, but for the most part it would be fixed. So those are the two solutions that I would suggest that you explore. Obviously you can come up with your own solution as well, as long as it makes sense within your gameplay. So that wraps up the basic player control component of this project. We'll push forward and talk a little bit more about obstacles, rough out some basic goals, and then think about the overall design of our level. But we'll do that in the next presentation.